Okay. So what we're going to talk about over this week is the two special types of logarithms. And here's the good news. They're used so often that your calculator can evaluate them, okay? Whereas the other ones, we just had to figure out, okay, what's the exponent that would give us that number? Okay, so the one we're going to study for today and tomorrow is a common logarithm. A common logarithm is a logarithm of base 10. Okay, and it is written as just log of x. Okay, so do you notice that we don't write the 10 in there? If you would like to write the 10 in there, you may, but it's just kind of common knowledge if I'm writing this logarithm that it is base 10. So unlike other logarithms, common logarithms can be evaluated using your calculator. Okay, so the ways, if you see that today, if you see just this, what that means is it's not written down, but that means 10 to the y equals x. Okay. Because I can use it or use my calculator to evaluate it, there's a couple different uses that we're going to look for today, okay? The first use is that there are several logarithmic scales that are based on log base 10, okay? Two that come to mind that are probably familiar to you are the Richter scale Does anyone know what the Richter scale is used to measure? Who's heard of it before? Okay. Do you want to share with us? No. Not sure?
I've heard it before.
So, a couple weeks ago, did you hear about there was an earthquake on the East Coast? And did you hear they gave it a rating? It's called a Richter scale rating, okay? So the Richter scale is a log scale that measures the intensity of an earthquake. And here's what you need to understand about a logarithmic scale. If I'm changing the Richter scale reading, remember a logarithm is an exponent, right? It actually, if I change it by one level, it actually changes the intensity of the earthquake 10 times, okay? Because it's 1 power of 10. So when you start changing things on the Richter scale, even by a little bit, those earthquakes become quite a bit more intense. All right, so that's one thing. Here's another one. And you're going to see in a second, we're going to just plug some things into our calculator. But just be aware, these are things that have a common log in them. pH scale. Who's heard of this before? Okay. pH scale in chemistry measures how acidic something is. Kind of the same deal. If you move 1 point on the pH scale, either to more acidic or more neutral, that changes it by a power of 10. Okay, so it actually is increasing or decreasing by quite a bit. And then the one we're going to look at is a decibel scale today. I'm assuming you've heard of decibels. What do decibels measure? Tate?
Sound.
Thank you. Sound. You're saying it in your head. You guys just don't say anything out loud. So decibels measure sound. Once again, the same deal. It has the log base 10 in it. And so if you change something by 1 decibel, it actually changes the sound intensity by quite a bit. Okay? So what we're going to need for this is, I think, well, this should be music. What I think we're going to need to do is make sure we have our calculators out. So if you don't have one yet, I'm going to give you a moment to grab one. Okay. So different textbooks that I've looked at have used different variables. This one is saying that this L, which a lowercase l and a capital I look this a lot the same. That capital L is going to go right there. The loudness L in decibels of a sound is equal to 10 log of I divided by M, where I is the intensity of the sound, so kind of keeping that in mind in a minute when we're solving. And M is the minimum intensity of a sound detectable by the human ear. And then L is the decibels. So, residents living several miles away from a concert venue can hear this should be, I'm sorry guys, this should be music, of an intensity of 66.6 decibels. So I'm going to stop right there. This is decibels, that's L. So I'm going to highlight, because I'm using colors, I'm going to highlight mine in blue. In a moment, I'll put that in over there. How many times the minimum intensity of a sound detectable by the human ear was this sound if M is defined to be 1? So it sounds like I'm looking for I, the intensity. All right, so let's plug the things in this problem. Then I'm going to show you how to work around with the logarithm. First of all, over here for my L, I'm going to put my decibels. And I'm just going to write the equation. I have 10 times the common log of I, which I do not know, and then divided by 1. Okay. And keep in mind, this is what I'm trying to solve for. Now, I know it's been a bit, so I have to make sure that you remember everything. When we were rewriting logarithms before, what we would do is we would get the log alone, and then we'd rewrite it in exponential form. So the first thing I'm going to do is see that 10 in front. I'm going to go ahead and I'm going to divide both sides by 10. What's 66.6 divided by 10? Doesn't that just move the decimal over 1? So we have 6.66. Also, are we all comfortable with the fact that I divided by 1 is just I? Okay. So once you've isolated the logarithm, we're going to go up here to this statement. And to get rid of a logarithm, you can't like just divide it off or whatever. We have to rewrite it in exponential form. So remember what we talked about. If this is written, the base of this log is 10. Okay, so I'm going to say 10 to the other side, 6.66 equals I. And so this is basically telling you how much more times intense it is than the smallest detectable human sound. So let's actually then see what we get for that as a numerical value. It might actually not, yeah. That's what I get when I plug that in my calculator. Confirm you get the same thing. So what that tells me is 4,570,882 times more intense. Okay. All right, so one of the uses of the log base 10 is to deal with a logarithmic scale. Second use, think the one that you're going to use more often. It is used to solve for an unknown in the exponent. solve for an unknown in the exponent. Okay, so this is the part that I don't know how much you remember from before. Do you guys remember, I will refresh your memory if I can find it, that we talked about how if you have a log to a power, the power comes down to the front? Okay, so what that means is if I want to get an exponent down to the front, I am going to go ahead and take the logarithm of both sides to do that. So here's how this works. So you're going to be given something where you have an unknown in the exponent and you don't know the answer, okay? What do I mean by that? 4 to the first is 4, right? 4 to the second is 16. 4 to the third is 64. We don't know exactly 4 to what exponent equals 19. So what we can do is we can use the common log to bring the exponent down to the front. So equation solving 101. When I do something to one side, you fill in the blank. Do it to the other side. What I'm going to do is I'm going to take the log of this side. Because I took the log of this side, I'm also going to take the log of the other side. Okay, that's our first step. What that does is it takes our log properties from what we were talking about before. If I have the log of 4 to the x, that x comes down to the front. So now I have x times log of 4 equals log of 19. Because your calculator is going to evaluate these, I'll show you in a second, you can solve for x by dividing both sides of this equation by log of 4. Okay, so you do that. Let's grab our calculators out. So the common log on these ones is in this left column, so it's right here. Let me look at, where it is on these ones, I always forget. Ooh, does this one, does it not have one? Oh, it's right here, right in front of my face. Do you see it's right under the second? Thanks, Wendy. Yeah. All right, so this log of 19 divided by log of 4, and I get 2.123. I'll call that about 2.1. I'll use an approximate sign. Okay, I hope that makes sense to you, because think about it. Remember how we said 4 squared is 16? So it would make sense that it would have to be a little bit bigger than 2 to give us a 19. All right, let's try one more. So same concept here. This time I have a whole x minus 3 in there. That's fine. I am going to go ahead and I'm going to take the log of both sides. So I have log of 3 to the x minus 3 equals log of 25. That is going to bring that x minus 3 to the front. Now I have x minus 3 times log of 3 equals log of 25. Now what? Now we're going to divide by log of 3. And there's just one little extra step on this one at the end, but all right. When I do that, so I have log of 25 divided by log, common log of 3. I get we'll call it 2.9. So x minus 3 is about 2.9. So the last little step on this is I still have to add 3 to both sides. So that would be x is approximately 5.9. All right. What else did I put on here? Ooh. We'll save this one for tomorrow. Okay. I think you probably can figure out, you have to move the 3 first, but we'll save that for tomorrow because I've already been giving you notes for about 15 minutes today, so I think it's time to do some practice. So what we're going to do is, I want to make sure you got this nailed down. We're going to grab a whiteboard and marker if you haven't already.